We gathered to talk about Xamarin and Azure Maps and how we can create a navigation app using those tools. So by raising your hands, who remember those times when we used to walk around or drive with those maps? Okay, cool. And whoever actually drove somewhere using such a map? No one? Okay, one guy. So pretty young audience, okay, that's cool. So let me share my personal experience regarding this. I was about the age of maybe 8 or 9. Me and a friend, we drove to ice skating range to have some fun, and his dad was driving the car. We got into the car. We live in a small town, so the ice skating range was out of town. And we got to the car, start driving, everything's nice, and his dad was not using a map. So I figured, okay, cool, he knows his way around. And midway, I suddenly noticed on the dashboard, he has a small electronic device. It didn't show the full map, but it did show the exact place where we were driving. It moved along with us. It showed the next turn and when we need to do this turn. And even it showed when we're going to get to this ice skating range. Obviously, I'm talking about a GPS navigator, but for me, this was the first encounter with this technology. For me, it was super innovative. I was really amazed on the spot. I thought hundreds of engineers probably made this happen. But luckily today, we have so many options. Each one of you can just go to the App Store or Google Play and just download whatever navigation app he likes and use it on his own smartphone. So let me introduce myself. Hi, my name is Pshul. I was actually born in Ukraine, in a lovely city, Lviv, but moved to Israel when I was very young, so I don't really speak Ukrainian, but I do understand Russian, so feel free to talk to me in Russian if you want. For the last 8 years, I've been professionally working with .NET technologies mostly on the client side, which made Xamarin my passion. I'm also an OSCode evangelist, so if you're not familiar with OSCode, come talk to me, I'll tell you all about it. It's a very cool debugging tool. And feel free to talk to me about any of those topics, anything software, hardware, gadgets, games, animals. I'm a big animal lover, so you're welcome to talk to me about this. Okay, so who ever worked with Azure Maps? Okay, sure, no one. It was only introduced in the last spring at the build. It was introduced as generally available. So what is Azure Maps? Azure Maps is a new partnership between Microsoft and TomTom, and they provide geospatial services for everything you might need for map work. So we have, obviously, the maps themselves, which we can use APIs to get, anything that's connected to routing, search, time zones, and traffic. And everything we use with the familiar concepts of Azure. So it's a REST API and different price tiers. Although currently there is only one price tier, but probably if it will get more popular, we will see more price tiers to make our lives cheaper. Okay, so how Azure Maps compares to the big companies over there, to the big services. So obviously we have the Bing Maps, which is also by Microsoft, and we have the Google Maps by Google, obviously. The main difference is by map coverage. So each service has its own map coverage and covers different areas. Each company and each service has its own website with a huge list, which I'm not going to show for obvious reasons. For instance, if you are planning to do some map work in India, I would advise you not to use Azure Maps. They support major cities only and nothing more. So if you are planning for a specific geographical location, I suggest you go first to check the coverage. The APIs are also different. So Azure uses Azure-based API, which we all know and love. Bing Maps and Google Maps use their own dedicated API. So you will have to learn the logic, the internal logic of those APIs. Also, the sources of the maps and all the data is also different. So Azure Maps, as I mentioned, they're working with TomTom. Bing Maps is working with Here Maps, which was acquired by Nokia not so long ago. And, well, Google Maps uses Google Maps, obviously. Although, after the acquisition of Waze in 2013, I think, they also use some data from Waze, mainly incidents and such. But, after all, everything comes down to money. Every service that we use, we are going to pay for it, so we need to take this into consideration. So Bing Maps should be out of question if you are making something small, because their pricing is usually for more enterprise and starts from thousands of dollars just to use it. Google Maps recently changed their pricing, and now it's a bit more expensive. So let's go over the Azure Maps pricing to see it's pretty comfortable and well built. So maps and traffic tiles, everything that we need to show the map itself, we have each month 25,000 free calls. For other smaller services, we have just 5,000 free calls, and everything else that is not mentioned, another 25,000 free calls. After you exceed your limitation of free calls, you will pay for any service just $0.50 for each 1,000 calls. Except for IP to location, which is just a quarter. I'm not sure why, maybe because it's a preview. We'll have to wait and see how it goes. Okay, so let's talk about the groups. Who recognizes this map? Anyone? I see some laughter here. Cool. So for anyone who doesn't know what this is a map from Elder Scrolls V Skyrim. This is a fan art map. And we'll talk about what render gives us. So basically, render provides us with everything that we need for copyrights. If we want to show just the general caption, it will probably show something like TomTom 2018 or the year when you're going to use it. We can show for a specific tile the copyrights or the entire world. Also, if you have just a small portion of the map, obviously you can use some bounding box to retrieve all the copyrights for this bounding box. Also, we will have the map tiles themselves. We can get it as images, which will be regular PNG images, and tiles, which will be vectorial. The idea is simply you provide an X and Y and a zoom level, and you get a rectangle of a map. Okay, so next is route. Route, we can get directions from point A to point B, just like any other navigation app. And we can use get or post, depending on our needs or what we prefer. And there are lots and lots of different query parameters, lots of them. This is just a small portion. I really encourage you to go and check what other options there are. So for instance, we have the travel mode, which is the interesting part here that Azure Maps supports not just walking, bicycle, and car, as we know from Google Maps, for instance. It also supports trucks. So if we choose travel mode by truck, it will actually limit us to tunnels and bridges that are not supposed to get trucks. Okay, so the next group is search. Obviously, when we had the maps, these big maps, the physical maps, we had some index page where we looked what we want to search for, and we had the X and Y of the tile. But today, any navigation app or any map that we have on the phone will have a search option. So what we can do with the search? We can search for an address. We can do it by free text or by something more structured. And we can have the reverse search. We can provide the geolocation and receive either a street or a cross of streets. We have the fuzzy search. Fuzzy search basically is what you want, right? Just give me a text and I'll give you back everything you want. It might be an address, it can be a point of interest, or anything you wish. obviously, which leads us to the point of interest. Point of interest, we can search regularly for just a point of interest. We can search nearby locations. So for instance, if I want in the radius of 5 kilometers find something, I will be able to do so. We can search by category, if I want to search only for restaurants, for instance, and along a route. So if I got a route and I get these details, I can search for example, a gas station along the route. Inside the geometry allows us to actually search inside a geometry of geolocations. So if we want in a city or some streets, we may provide this data as well. Okay, time zones. Who knows this guy? Cool, nice. This video has actually saved me a lot of time. Those guys explain about anything that's software related. This is the YouTube channel Computer File. And I had to explain my wife why we as coders hate time zones. And this guy just nailed it. He explained it so well that my wife hates time zones as well now. Okay, so what we can have with time zones. We can retrieve a time zone by a geo-coordinate or by an ID. Which ID? Well, we have two enums. We have the IANA, which is a world standard, and we have the Windows enum. Since IANA is a world standard which all the time progress, we can get the version, and we can also convert from Windows to IANA. Now traffic. Any navigation app today supports traffic. I use a navigation app every day because to get to my work, I have two main routes. And it really depends on the traffic itself. So we can get the flow of the traffic, we can get a segment or for a specific tile. We can get anything related to incidents. So we can have details about an incident and every incident in a tile. Every incident in the viewport is well supported, just like we search for a point of interest in a bounding box. Now, this covers everything that we need to know about Azure Maps, just to give you some taste of what it can do. Now, about Xamarin. Who actually tried something to write in Xamarin? Okay, not a lot of people. So Xamarin, just to align, it's a tool for cross-platform developing, which allows us to write once and deploy to several platforms. It has pretty rich history. Don't be scared, we're not going to go all over it. But there are a few key points that I would like to mention. So everything started when Mono was launched way back in 2001. Mono set for its goal to run GUI clients on several platforms, not only on Windows. Fast forward 10 years, everyone who worked on Mono was laid off by another acquisition of a company, and the guys organized into a new company called Xamarin. 1 year later, Xamarin provides us with Xamarin.Mac, which really gives the boost they needed this whole time. 4 years later, Microsoft acquires Xamarin, I heard for a huge amount of money, and now we have it for free in the Visual Studio Community Edition even, and we can use and try it. So how it works. So this is a general diagram of how things work in Xamarin. So we have shared business logic, which we write once, and it will be used in all of the platforms. And we even have a shared user interface, which is very important because we don't want to actually write all the mundane things several times for each platform. We want to share as much as we can. Although we can write for a specific platform. So if we choose to show something different on a specific platform, some specific color or specific, behavior, or we want to, let's say for iOS, we want to use the Face ID or the Touch ID. This can be used by a specific API on a specific platform. We write in C#, and user interfaces are in XAML. So if you have any experience with WPF, you should be very familiar with what's going on there. Very easy, very nice. Okay, so let's talk about the navigation app we are going to actually build right now. So, yeah, I'm very innovative with names, Xamarin and Map, Xamap. Yay! Okay, so let's talk about two main tiers of our application. We will have the services layer. Services layer will provide us with every detail that we actually need to get information to our application. So we have three main services. We have the navigation service. Navigation service is responsible for everything that is navigation related. When we start the navigation, when we select a route, and since we are not going to actually take the laptop and go outside to walk around to see how it works, I implemented an event for mocking our movement. Also, we will have the map calculations. Map calculations will have all those methods that we as developers don't like to think about. We just Google them. Give me the distance between two geolocations. Calculate the rotation of the map by two geolocations. Basically, to be honest, I just copied from Stack Overflow the main logic and created some nice service out of it. And this is the service we are actually going to see how it's written. So this is the search service. We are going to use anything that we need from the cloud, which means the fuzzy search. We will get all the results. And from the results, we will get all the directions for each of the results. Okay, so it's coding time. Let's see how it's done. Okay. Is it okay here? Let me see. I lost my mouse. Okay, here it is. Cool. So let's have a short look at our solution. So as you can see, we have for Xamarin 4 projects. We have our common project with all our shared user interface and logic. And for each platform, we have its own dedicated project. So all the service, since it is shared, is going to sit here in Azure Maps, in the shared logic project. So let's see how the service itself looks like. So we have this nice folder and search service. Okay. So if you're familiar with Azure, we should have a key that we want to get for our subscription. To use the actual maps, we need to, can you see it like this? Yes, okay, cool. So we have the required parameters here, which we need to send for every request. So we want to get JSON as a result. We want to provide the subscription key, and, well, there is only one API version for now. We initialize some sort of an HTTP client from the constructor with the base URL atlasmicrosoft.com. This is the base URL for all of our Azure Map needs. Now we have here 3 stub methods: the fuzzy search, the get directions, and the convert response to object. Now this is a helper method which I would like to just get rid of it right now and just to tell you what it does. So basically it gets a response and reads all the string. I know it's a JSON, obviously I requested it. And using Newtonsoft, I converted to some data object. Nothing too scary about it. So let's see how the fuzzy search works. So as you can see, again, not much here, just 2 lines of code. I use my HTTP client to get the response. I call the search group. I call the fuzzy API. I provide the required parameters and send in the query. The query is a simple string which the user will provide us. This is what he wants to search for. I call my helper method and get the object. Now the object I sent is a fuzzy result. So if we dive in, as you can see, this is a simple DTO, which I just used a regular online tool to convert JSON to C# classes. Okay, so the get directions is a bit more interesting. So get directions receives 2 parameters. the start position, and an array, which I send as params, of the end positions. So as you can see, we have here a private method, which simply takes the geolocation and converts it into a string by the format Azure Maps actually expects us to do. We combine everything, the destinations and the initial position, and create out of everything a query string. Now we call again our get via the HTTP client. Now here we call for the root group for the directions API. We pass the required parameters, and here we have some of those optional parameters I talked about. So we have the instruction type, which I provided the value of text. As a navigation app, we need to provide our user when he needs to turn and how, and also some text for explaining on which street he's going to turn or which way he should take. There are several different options here. I choose text for obvious reasons. You can provide also a language. They support several languages, but since we are going to use English, I just omitted it. Now, there is also a root type, which we chose to be, well, obviously the fastest. We don't want to get stuck somewhere. And then we just send the query that we just created this huge string. And again, we convert it into an object. So nothing too heavy, nothing too really complicated about it. It's very simple. If you ever used any Azure services, you see that this is basically the same, very easy and very intuitive to use. Now let's talk about the presentation layer. So in Xamarin, we use MVVM. You don't have to use MVVM, but from my personal experience, you are going to save yourself a lot of time if you are going to use MVVM. Even for small things like this navigation app, MVVM is going to save you time. We are not using any frameworks, any MVVM frameworks, just to make the example as simple as possible, but I do encourage and strongly recommend you use at least some sort of a framework. My personal recommendations are the following. I am a huge RX junkie. If you know what reactive extensions are, you know what I'm talking about. So I advise to use reactive UI. It makes your UI actually reactive. Well, the name stands for itself. If you want something smaller with less code and maybe you don't like React, I suggest you use Calibre Micro. Very nice small library with a lot of, let's say, magic that happens behind the scenes. And if you want something more mature, obviously we have the Prism, one of the first libraries of MVVM, I think, if I'm not mistaken. Now, since we are using MVVM, we have, for each logical part, we will have a view and a view model. We are going to use some converters to make the changes from the view model to appear nicely on the view. And since we are using Xamarin, we need to support several platforms. We are going to use a custom renderer for our map. Okay, so let's dive in. Let's see what we have here. So this is how our map is going to look. As you can see, here we are at the Cosmopolitan Mall. And this is the main page. This is the component called the main page. It has view and view model. It's a master detail page. It will initialize all the other views and view models, its direct children. It will allow us this nice hamburger button that you see here, which will give us the side panel with the search option itself. We're not going to see how it's written. It's very technical with not too much logic, so I wouldn't like to waste time on it. So let's move to the next one, which is the search panel. Comes from the side, shows us options to search and to select a route. So it will utilize our search service we just saw. It makes a fuzzy search from the provided string and receives all the possible routes for each of the results we are going to get back. It shows the details. For instance, as you can see, it shows the kilometers we need to drive to that location. So let's see how it's done. Okay, cool. So I remind you here, we have our common project. We go to View Models, and we have the search pane view model. Okay. So nothing too complicated here. We have isBusy Boolean property just to show indication of work that it's busy. We have two properties for the results. One is an array of results that we are going to receive, and it's bound obviously to the view, and the selected result, which is bound also to the selected option of the list that the user will just tap. Inside this setter, if you remember, I talked about the navigation service, so we update the selected route based on the user selection. This will raise an event which called selected route changed. We are going to use it in later, so remember this part. Now we have a command for actual search, which we initialize from the constructor with the method search. Now search is going to do very little work, but it is going to do something. So we just check for our query that it is viable. Reset the results, start busy, do logic, stop busy. Let's see how it goes. Okay, so we call our search service, as you can see here, with the query for the fuzzy search with the query we got from the user. After we got all the results, we get our current location via a cross geolocator, which is a tool that provides us our current location in Xamarin. We convert it into a geoposition that we can actually use with our search service, which has basically just a latitude and a longitude. For each result, as you can see here, the fuzzy results, for each result, we call the load routes method, which is a helper method right down here, which we're going to look at it in just 1 second. Once every route is calculated, we eliminate all the null values for sanity checks and set it to our array to the property, which is bound to the client. Now, loading routes is even easier. We have the current position, and we have the fuzzy result, the specific result we are talking about. We call the search service with the get directions from our current position to the position of the fuzzy result. We get back the directions, and if we actually got directions and everything worked fine, we create a search result view model, which is bound to this little guy here, to one rectangle of information. That's it. When the search happens, all of this code runs, and we get this nice little screen. Okay, so what's next? We got the main page, we got our search pane. Well, now it's time to work on the action panel, right? So we need to provide users some information and let it start navigating. So after destination is selected, we need to provide an actual option. So this is this little play button that we have. Once the user actually starts navigation, we want to switch to this view, which will provide him details about when he needs to turn and how, and, well, to which street, some instructions in written language. I used those icons from Mapbox. They're free, they're nice, they have lots of formats, so if you are planning to do something similar, I really encourage you to check them out. They have all the solutions that you might need for icons. And obviously, as you can see, our play button changed to a stop button. Well, because we also want to stop the navigation. Okay, so again, let's see how it's written. Okay, so again, we're going to the View Models folder, and we have the Action Panel View Model. Now here, we are going to have a bit more properties, but again, nothing too difficult. We have the next instruction index, which is the index of the next instruction we're going to show for the user. We have some Boolean property for are we navigating currently or not. The selected route, since we are going to actually show something from the selected route, which are the instructions. Property to bind from the view for the actual next instruction with all the data, including the text and which maneuver we need to do. And some calculated data for the meters to next maneuver. Two commands for start and stop navigation, which basically just map to the navigation service. Inside the constructor, we talk with the navigation service to initialize all those properties and to subscribe to the relevant events. Once we have all the events, we can actually update the selected route, or if we are starting to navigate, we want to initialize the is navigating and to drop the next instructions. Also, here is an event that I talked about, which is going to mock our movement. It will raise each period a new location, just like we are moving with a new geolocation. As you can see, update instruction here. So in the update instruction, we need to do two things. First of all, we need to initialize the distance to our next maneuver. We want to show the user in 100 meters, turn right, right? In update current instruction, we actually need to check if we have the next instruction, if we reached for the point we need to update our instruction, and if so, we need to update it. So let's see how it's implemented. So meters to next maneuver is pretty easy. I have the next position, which our new position, and the position of the next instruction. So do you remember this service I told you about, the map calculations, that no one really wants to write about it or talk about it? So we have a method there called getDistance from lat long in kilometers. You provide it with basically 2 points, 2 latitudes and 2 longitudes, and you get the distance between them in kilometers. Since we want to show it in meters, we just multiply it by 1,000. And we initialize our property, which is going to be shown on the view. Next, we want to check if the next instruction index exceeded our last instruction or not, and if so, we don't have any more instructions, just return. Finally, we check if we got to our next instruction point, obviously with some sort of tolerance. With some sort of tolerance here. And if so, we access our selected route, guidance, instructions, and using the index that we just incremented, we initialize our next instructions property. That's it. That's what is actually going to make all of this happen, all of this action bar to actually work. So the last part. Do you know what it is? Any ideas? Obviously, we're talking about the map. This is the main part of our application. We need to show our map, and it should be interactive for the user to see what we're talking about. So it is going to be a custom control with a custom renderer, because we do want to do several different things for each platform, and each platform actually behaves a bit different for any map calculations or map visualization. So after a user selects a route he wants to go to, we want to show an overview of the route. Once the user presses the navigation button, the Start Navigating button, we want to zoom in to show this nice little arrow of driving and to actually update our map according to the movement. So here it is going to be a bit more interesting. So what we're going to have here, two things. Inside our common project with the common logic, we're going to have this Azure Map custom control. Okay? So as you can see, it's just a class that derives from the generic map class of Xamarin, and we're going to add a few things to it. First of all, we want to add the bearing. Bearing is the rotation of the map that we are going to have. Once we navigate somewhere, the map should rotate with our movement. We're calculating it from the current location property. As you can see, just before setting the new location property, we are calculating the bearing again from the map calculations service. We just provided the current location and the new location, and it does the magic for us. Also, we're going to have the selected route because we want to actually show an overview and to highlight the route on the map. In the constructor, if you remember, this is the event that I mocked to make us feel like we're actually moving. It will be raised each, I think, 250 milliseconds. And we're going to simply update our current location based on our new position. Also, once the map starts, we're going to initialize our current location. Now, this is just the logic for the map. It's nothing about rendering yet. So let's go for the specific platform for Android to see how it works. As you can see here, we have the Azure Maps renderer. Now, here we define how we're going to render our control. Each control, and it doesn't matter if it's built-in or not, has a renderer for each platform. We're just extending the currently available map renderer. So as you can see here, above the namespace, we provide an export for a renderer for our Xamap custom control, and this is our custom renderer. Here it is, here it's defined. It actually derives from the map renderer itself and just extends a few options. So we have also an implementation of this Google Map interface, which allows us to call this method on map ready. All we want to do is set on map loaded callback, which is also this one. And after all, here on map loaded, we initialize current location inside our map. So we make sure that once the map is up, we actually see our current location. Now, the interesting part in custom renderers is that we can listen to a property change of the custom control. We are going to get inside the event args the property name that actually changed. So if our current location changed, we want to update the driver location, obviously. And if the selected route changed, we want to show a route overview. So these are the two tabs. So the update driver location is pretty easy, right? Get the driver location and just update the camera. It's nothing too difficult. The show route overview is a bit more problematic. So we need to clear the map from previous highlights. We need to create the polyline options to select how we're going to actually show it, calculate all the route points, create a camera update object, and actually update the map. So let's see how it works. So the update driver location, as I said, it's very easy. Android works with its own dedicated object for latitude and longitude. It's called lat_long. We initialize it by using our Xamap current location, latitude and longitude. Once we have it, we create a camera position, which is basically the current position, some zoom level, the same tilt we currently have on the map, and the bearing we just calculated on the custom control. Once we have the new position, we create a new camera position update. We called it rotation update, and simply call the native map animate camera. This will do all the work for us. It will do a nice animation to actually update us to the new location. Now here's the more difficult part, the show route overview. The show route overview, we need to obviously clear the map. We created some polyline options. We chose a color, we chose the width, and now we need to populate the points. So we go to our custom control, we get from the selected route all the legs of our route, we select all the points, we convert them to the same Android lat_long object, and throw it into array. Once we have this, we set all those points to the polyline and add it to the map. Cool, now we have our map highlighting our route, but we are still not zoomed out to actually see an overview of that route. Luckily for us, we have this nice builder for lat_long bounds. We provide it with all the points, as you can see here, builder include and give it a point. And once we build it, we get nice bounds to actually include all of our points. If we want to create an update for the camera, we also have this nice new lat_long bounds, which even provides us with an option for padding. Once we call the animate camera, Everything animates and gives us a nice overview of the application, of the route. Okay, cool. Looks like everything's done, right? We wrote everything. Everything should be working. Yeah, we are done. So let's see how it actually works. Okay, so this is our nice, neat emulator. Let's just make sure that we have everything set up. Okay, so as you can see right now, we're in the Cosmopolitan Mall, or at least near it. Okay, so we want to search for a location. Where we should go? I heard there is a nice street, and please, if I'm making a mistake, don't judge me too much. Shatik, something like this, right? Anyone? Yes? Oh, sorry. Right. So this is the way, right? Okay, so I want to go to Krushatik Street in Kyiv. Now, what's happening meanwhile? It makes a fuzzy search to our Azure Maps services, gets all the results, and for each result, it went and got all the directions. As you can see, we have several locations on the street that he is willing to provide us with information for. We can choose, for instance, this place. As you can see, we have a nice animation to this place, or we can go back and choose another place. So once we hit the play button, as you can see, we start navigating to the location. As you can see also in the action panel, we actually have everything updated, all the meters. I did some roundup, so we won't just have some nonsense numbers. Each 100 meters, it advances us for the next location, and once we actually get to the turn, it will also update the text. So now it's turned right onto Herman. No, I'm not familiar with those places. I'm sorry. Obviously, we can stop and get back to our current location. Okay, cool. So this was a short example of what you can achieve with Azure Maps and Xamarin. To summarize, as you saw, it's pretty easy today to build a navigation app using the current tools. All you basically need to do is the following. Choose an API for all your map needs, right? So there are lots and lots of options and many more options. I didn't talk about all of them, obviously. All you need to do is make a search for whatever you like to go to and get directions to all of those places. And it doesn't matter if it's an Azure map or Bing Maps or Google Maps or any other service. Use a tool to develop cross-platform. Once you have a tool that you write the code once and you deployed it to several platforms, you're going to save a lot of time, not just developing, but also for maintaining. You're not going to handle bugs that you might prevent if you have just one single code base. Very easy, in my opinion. I don't know. So what's next? My suggestion for you is to explore all the possibilities that Azure Maps provides. As you saw from the group's overview, we have lots and lots and lots of options. Not just routes, not just search. We have time zones and a new service which we didn't go over it called IP to location, which you also can look for it if you need something related to locations and IPs. And obviously, I suggest you go dive deeper into Xamarin. Xamarin is a great tool with C# and XAML for everything you need to develop cross-platform applications. If you really want to go into it, I suggest for Azure Maps, go to their official documentation. There is no better place, really. The documentation is just amazing. They have everything very detailed with great examples, and the new documentation in the Microsoft Docs even lets you to actually run specific APIs, just provide with your Azure subscription key, and you can just go and try things for yourself without actually creating any application. For Xamarin, obviously you have the Xamarin documentation, which is nice. It's cool to get to know things and to play around a bit, but if you really want to go deeper And to learn the more interesting stuff, I suggest you go to Xamarin University. Great place with great lessons that you can follow and learn the really deep things. Also, the slides and the code itself will be shared. It is already shared on my GitHub. So if you want to download it and play with it around a bit by yourself, you're more than welcome. That's it. Thank you for your attention. I'm free for questions.
Что, нет вопросов? Спасибо тогда за презентацию вам.
Yes, thank you for your presentation. Very interesting. I have a question about the rendering of the map on the smartphone screen. We need relative coordinates and how to. We need some special control, or it's standard opportunities of the control Xamarin. How it.
Okay, so if I understand your question, you mean if we need to make some specific adjustments for each platform?
Yes.
So basically, once you use the map control itself, each platform going to provide with its own map control. So for Windows, it's going to be the Bing Maps control, or just the Maps control. I'm not sure how it's called today. For Android, it's going to be Google Maps, and for iOS, the Maps from Apple. If you want to make any small changes, the geolocation is standard for everything, but the specific customization you will have to do on each platform.
Thank you. Yes, I got it.
Okay, and one small question regarding the control for the maps itself. So you mentioned that there are each platform provides the default ones, and for example, if in Ukraine it's not a good practice to use the default iOS controls, for example, because they are not so detailed. Maybe you have some experience of using some kind of OpenStreetMaps control or something like that.
Okay.
In order to replace the default rendering logic of the platform and to use at least some third-party components. Is it feasible to do, and have you tried to do it in
Okay, so I haven't tried the Open Maps control. It is obviously possible, even with Azure Maps. They do provide you with tiles and images, and you can just build it any way you like, as long as you have the actual locations that you want to go to and the XY coordinates of the tile itself and the zoom level. You can make it cross-platform for all the platforms to support whatever you like and write it once. Or if specifically for the iOS you want to change it, you just change the custom renderer on the iOS platform. Everything will work natively except iOS, which you can integrate whatever you like.
Okay, thank you.
Это все. Спасибо вам большое.
Thank you.